All right, in this video we are going to talk about angles. So first off, we'll start off with the definition of a ray. And so what a ray is just essentially a half line. So you start off with a line and then you pick some point on the line. And then what you'll do is take all the points on one side of the line. Okay. And so that's essentially what a ray is. It's a half line. So that point that you pick is called the end point of the line. And in this case, it's labeled as E. If F is any other point on the line, then you can refer to that ray as EF. And it's usually denoted with this little kind of half line over the top of EF, although we probably won't use that too much. Okay, but that's what a ray is. It's a half line. Okay, the other half of this line would basically be extending over here to the left, but we just pick some point that's on the line and then take all of the points on the line that are on either one side or the other. Okay. All right, and so that leads us to the definition of an angle. An angle is the union of two rays that have a common endpoint. So right here we have this ray, the ray EF, and then the ray ED, and you can see they have this common endpoint E right here. All right, so and so the two rays with the common endpoint form an angle, and that common endpoint is called the vertex of an angle. We will deal with angles quite a bit in this class, and so the way that you would denote the angle is with the three letters. Like say if you have rays ED and EF, this angle DEF can be either denoted as angle DEF like this. So you can see the little angle symbol here, D, E, and F, or it can also be referred to as F, E, D. Okay. The only requirement really is that the endpoint, the common endpoint, the vertex, whatever letter is associated with that, needs to be in the middle. Okay. So that's how we would specify angles in terms of the points and endpoint. All right, in our class, it's going to be useful to think of angles as being dynamically created. Instead of a static thing like the union of two rays like that, what we're going to do is think about rotating one side of the angle around the other ray. So one ray is going to be, we're going to think of as being moving, and the other ray that forms the angle, we're going to think of that as non-moving. Okay. And so just as an example here, if you look at this Desmos page, and there's a link to this in our class, you can see if you rotate this little slider around that one of those rays that form this angle here rotates, and the other side stays put. It doesn't move at all. So that side that doesn't move is called the initial side, okay, of the angle. And the side that rotates is called the terminal side. All right. And so it is just really useful in a number of real-world applications to think of angles in a dynamic sense as not just, hey, I have two half lines that have a common endpoint, but that this terminal side was rotated, right, about the initial side like this, and it stopped somewhere. Okay, so again, the side that stays put in the rotation is called the initial side. The side that gets rotated around is called the terminal side. One thing about these dynamically created angles that causes a little problem is if you just draw the angle like I've drawn it right here with no markings on it, it's a little bit difficult to tell like which side is the initial side and which side is the terminal side, right? Because you don't actually see the rotation. Now, if you're sitting here watching it like this, right, if you start like this and then you start rotating, it's pretty easy to figure out what way you rotated, which side didn't move and which side moved, right? But on paper, if you just see the end result of this, then it's really hard to tell which side is the initial side, which side is the terminal side. Which way did the terminal side rotate? In the clockwise direction or the counterclockwise direction? We don't know. Okay, so usually when you have angles or are thinking about angles as being formed by rotation, what you need to do is to mark that rotation. Okay, when you just draw it like I have here, it's not very clear because it hasn't been marked. So the way that you would mark it is with a little arrow that sort of is circular and kind of rotates around in one direction or the other. And once you do that, when you have it marked like this, it's much easier to tell which side is the initial side, which side is the terminal side, and what direction it rotated, right? So the initial side will be the, in the marking, say on this angle over here on the left, has to be this side right here because that's where the back of the arrow is. The arrowhead, right, will point to the terminal side. So that's the side that rotated. And so now that we know which side is the initial side, which side is the terminal side, we still, if it wasn't marked, wouldn't be able to tell the rotation, right? Without the marking in this angle here over here on the left, we might think that it rotated in this direction, right? Just right through here. But with the marking, it's clear that we rotated in this direction, right? Back around, and the terminal side wound up here. It could also be the case that it would rotate around 2 or 3 times and then stop here. So with the marking on the angle, it's really clear about the initial side, which side is the initial side, which side is the terminal side, what direction it rotated in, how many times around did it rotate. All of that is now very clear if you mark the angle. Over here in this angle on the right, we can see that this side over here would be the initial side, and this side would be the terminal side here. And we can see we rotated in this direction as opposed to rotating around this direction like this. Okay. You can see that these two angles have the same sides, right? But they are considered to be two different angles because of the fact that the rotation was different. Okay. Okay. To make things, analysis of angles, a little bit easier, then what we're going to do is define what's called a standard position for an angle. Okay, and it just makes it easier to work things out if we define the standard position. And so most of the time we will be dealing with angles that are in standard position when we're going to go through here in chapter 5. Okay, so an angle in the Cartesian coordinate system, so in an XY plane right here, is said to be in standard position if, number one, the vertex of the angle is at the origin, so at the point 0, 0. So you can see that this is at the origin, right? The vertex is down here. And the second condition that you need is that the initial side of the angle points in the positive x direction. So the initial side has to be along the x-axis over here. All right, so that's all it means to be in standard position. Number one, the vertex is at the origin. Number two, the initial side points in the positive x direction along the x-axis. Okay, so having an angle in standard position, or just assuming that it's in standard position, is going to help simplify some things that we have to do. And there's no real harm in assuming that it's in standard position either. All right, so the first thing we want to talk about is measuring angles. So the measure of an angle is a measure of the amount of rotation from the initial side to the terminal side. So how much did the terminal side have to rotate from the initial side to form the angle? All right, so in our class, we're going to use two different systems, the degrees, which is pretty standard. That's the most common one that people use in practice. And then radians is another very common one as well, and one that is used in a lot of applications. All right, so first talk about degrees. A degree is just 1/360th of a complete rotation. So this is a pretty old way of measuring angles. It goes back to ancient times, and 360 is pretty close to the number of days in the year. So that it's probably not a coincidence. It's a really old system of measuring angles, and it goes back to really ancient times. That's why 360 was used. All right, so we all know that sort of a quarter of one full rotation would be a 90-degree angle. And then if we rotated the initial side all the way around, right, until it got back to the initial side, and so it lined up here, that would be an angle of 360 degrees. So one full rotation is 360 degrees. One thing that you need to be a little bit careful of in this class is, because we're going to sometimes use degrees and sometimes use radians, then you need to always make sure that you put the degree symbol, right, when you're talking about degrees. So 30 degrees. Don't write that as just 30, the number 30, right, because we're going to see later on that we will use 30 angle measurements where you don't use the degree symbol. That will mean that it's radians, okay? So when we're talking about degrees, make sure that you always put the degree sign. All right, so next up are positive and negative angles. If the rotation of the terminal side is in the counterclockwise direction, then the angle is going to be a positive angle, all right? And if the rotation of the angle is in the clockwise direction, then the angle is going to be a negative angle. So here you can see that these three angles up here, right, all of these angles are in standard position, right? So they are all positive angles. So in this example, we rotated 135 degrees in the counterclockwise direction. So that would be an angle of 135 degrees. In this one, we rotated 210 degrees in the counterclockwise direction. So that is an angle of 210 degrees. Here we rotated 300 degrees in the counterclockwise direction, so that angle has a measure of 300 degrees. All of these angles down here are negative angles because the direction rotation is in the clockwise direction. So here we rotated 240 degrees in the clockwise direction. That angle is going to be minus 240 degrees. Here in this one, we rotated 150 degrees in the clockwise direction, so that's going to be an angle of negative 150 degrees. In this example, we rotate 225 degrees in the clockwise direction, so this angle is going to be negative 225 degrees. Okay. All right, and the last slide in this video, we're going to talk about quadrantal angles, and all a quadrantal angle is an angle whose terminal side lies on an axis, either the x-axis or the y-axis. So 0 is a quadrantal angle, 90 is a quadrantal angle, 180 is a quadrantal angle, and 270 is a quadrantal angle as well. So it would be 360 and 720, and many other angles can be quadrantal as well. All right, so those are just angles whose terminal side lies on an axis. All right, if an angle is not quadrantal, then that means that the terminal side does not lie on either the x or y axis. That means the terminal side will have to be in one of four quadrants, and we just go with the standard way that the quadrants are numbered. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if the terminal side of an angle lies in quadrant 1, then we'll call it a quadrant 1 angle. If the terminal side of an angle lies in quadrant 2, we'll call that a quadrant 2 angle, and so on and so forth. Same for quadrant 3 and same for quadrant 4. Okay, so that is it in this video. In the next video, we are going to talk about the other way or method that we are going to use to measure angles, and that is with the radians. Okay. All right.